Welcome to Cinemeric Live, application technology made easy, where we present Cinemeric-related topics in simple terms. Our video series is practice-oriented and will take up just a few minutes of your time. Today's topic is milling of freeform surfaces using a 3-axis milling machine. Our agenda. We'll start with defining the basic types of freeform surface machining, continue with the generation and handling of datasets, and finally explain the Cinemeric functions for machining these freeform surfaces. And as always, we'll also present a practical example. Today, as an example, we'll demonstrate the production of an injection mold. It's for a standard, everyday object, a toothbrush. A freeform surface is a surface whose shape is defined, for example, by control points and boundary curves. As such, the term falls under geometric data processing. In principle, of course, only as few axes as necessary should be involved during the milling or machining process, or as we say, as few axes as possible should interpolate. Let's look at this part, for example. These 3D surfaces can be easily milled line by line using a 3-axis 3D process. 5 axes are not required here because there are no relief cuts, for example. Even if this surface were not aligned planar to X and Y, but were slightly tilted, you could still apply the tool here, mill the surface, and swivel it back again. But 3D 3-axis milling is generally preferred so that as few axes as possible are required. A prerequisite for machining or milling freeform surfaces is a functioning CAD/CAM process chain. This CAD/CAM process chain consists of CAD, computer-aided design, CAM, computer-aided machining, and a post-processor, a subsequent process, as the name suggests. This means that what happens in CAD/CAM is subsequently translated into a text file. The text file is in a format that can then be read and interpreted by the Cinemeric CNC. In short, CAD/CAM, post-processor, and CNC form the so-called process chain. Let's take a detailed look at how the CAD/CAM process chain works based on our NX CAD/CAM system. NX includes everything you need to edit CAD data and add programming in the CAM area, and of course also the post-processor, which is implemented to obtain the machine-readable format at the end. Here's an NX example where you can see the work holder, tools, and machine table. Basically, everything that's also used in the actual production process. Let's mill the separation plane. This is the area where the 2 injection molds, the top and the bottom, come together and also come apart again, where they separate. As I already mentioned, this separation plane is then roughed and finished. Here you can see a 3D surface milling operation, which is now to be converted into this NC program. After clicking on this operation and moving it to the surface, we can compare the programming with the simulation to check that the whole process will actually be collision-free and reliable and function as intended. Let's simulate this here as an example. So now we're starting the implemented post-processor. It's precisely matched to the machine and the respective control system. This post-processor provides all the required information to implement on the machine what we saw in the simulation. This text file is imported into our Cinemeric and then verified using the mold making view as to whether we've actually selected the correct program. You can see clearly the toolpaths here. And with the plane function, the surface simulation or surface display is used to check whether the toolpaths are correct and whether the tool is moving along the correct path on the surface. One goal of outputting the NC program from the CAD/CAM process chain, that is, from the programming process, is to achieve the best possible point distribution. Because high-quality workpiece surfaces can only be produced if there's a harmonious point distribution. Here on the left, you can see a not-so-optimal point distribution after the NC output. This is one of the reasons for a poor workpiece surface. And on the far right, you can see a very harmonious distribution of points, the basis for a very good workpiece surface. How can all of this be implemented? The core of 3D milling with Cinemeric is our Cycle 832 high-speed settings function, which combines the top surface, top speed and top speed plus functions along with any contour tolerance, all of which can be changed here if so required. And it's the Cycle 832 high-speed settings function which is used to preset data for machining the free-form surfaces for the best possible processing. More about this in our practical section, which we'll do using the Cinemeric control system. There are two basic components in Cycle 832. One is the look-ahead function, and the other is the CNC compressor. We also call this function CompSurf. Look ahead is the name of the predictive and cross-block velocity profile with the highest possible speed. It performs definable rounding of corners. You can think of it like driving a car into a curve. You focus on the start of the curve, the top of the curve, and the end of the curve. And here you try to approach and touch these 3 points in such a way that travel is as harmonious as possible. Of course, this happens within milliseconds in the NC, but the principle is pretty much the same. And the CNC compressor combines the blocks, as it were, to produce smooth paths. We call them paths with constant curvature. This is a function which, as I said, is available to ensure that a curvature is not approached abruptly, but rather there is a steady connection past and across the points. Please note that the top speed plus function is an application-specific function. That is, a commissioning-specific function that is available after selecting top surface, but it must be commissioned by the machine manufacturer. That is, individually for each machine and the parametric contents of the control. Top Speed Plus can be used on Cinemeric 828D and Cinemeric 1. NC programs, that is, the output from our CAD/CAM process chain, can be up to several hundred megabytes in size. It always depends on how big the component is, what technology I use in the CAD/CAM program, and of course, how fine the tolerance is when I create finishing programs. This can vary from to. And if we're dealing with large programs, quite a few megabytes in size, then this will be too big for the CNC user memory because its storage capacity is limited. An elegant solution for this problem is execution from external storage media. External storage media can be networked drives, a server where the machines are networked, or the internal CF card or SD card on the Cinemeric 1, or of course USB flash drives and USB hard drives. This optional EES, or Execute External Storage function, means that the execution is from external storage media and ensures that you can work from external storage media in exactly the same way as from the NC user memory. In the Program Manager, as can be seen here, I can not only manage and edit the programs in the horizontal soft key row from the NC user memory, or from the integrated and connected external storage media, but also execute them directly. A highlight in Sinomeric when executing freeform programs is the interrupt point and block search. What does that mean exactly? If, for example, the machine suddenly stops in the event of a power failure and you want or need to continue milling at this point after eliminating the fault, activating the interrupt point function and then performing a block search will take you back to precisely the point where the interruption occurred. This is extremely reliable and time-saving. And how machining of freeform surfaces or milling of freeform surfaces works will show you directly in practice on the machine. Our finished workpiece is the bottom of the injection mold of our toothbrush mold. As mentioned, this is realized by the roughing operation, residual stock removal, and finishing. Here is our program, which we created via NX and the post-processor. Due to the rather large amount of data, we use an external storage medium in the form of our data server, and then access the server from the machine to load the program. Here we can also see our cycle 832, which of course we could still edit directly on the control after generating the NC program if necessary. Again, you can choose between roughing, finishing, or our top surface with the various surface qualities, where you can then set the desired surface quality. And when, as I said, after roughing, machining the residual material and finishing, this mold is then finished, we now have the bottom of our mold ready to join the top of the mold. The two molds are then joined to create a cavity into which liquid plastic is injected. After the cooling process, the toothbrush is then almost ready. Only the bristles need to be added afterwards. The whole thing would then look like this when it's opened. Now, let's take a look at how this works in detail. First, roughing. That is, the rough removal of the material. This is done using an end mill. This end mill removes material to such an extent that the ball mill can prepare a defined material removal for finishing in the so-called residual material milling process. This is related to the cutting pressure. Cutting pressure means that when the milling tool hits material, it encounters resistance. This resistance is only in the mu range, but it's nevertheless measurable and partly visible in the surface quality. And if there's a uniform finishing allowance, you'll have the same cutting conditions everywhere. The roughing itself is finished. Now, a ball mill will be used as a milling tool for the residual material. Residual stock milling is always based on the allowance, that is, on the material that's left after roughing, in order to provide a uniform allowance on all sides for finishing. As you can see, the distances between the milling tool paths are so small that a mirror smooth surface is created. And that's the actual goal of finishing. But as already mentioned, finishing is performed only as well as the client requires. In this case, it takes about an hour. An injection mold like this can be used to produce a large number of toothbrushes. We've seen that in free-form machining, 3 or 5-axis milling machines are mainly used, but most of them operate in 3-axis simultaneous mode. For optimum surfaces and machining speeds in tool and mold making, mastering the entire CAD/CAM CNC process chain is of crucial importance. Top Surface and Top Speed Plus are functions that set new standards in terms of surface quality and machining speed. Thank you for watching, and see you next time.